Students, welcome to our online classes. On continuation of our previous classes in AC motors, we have studied the performance of induction motor in previous classes. In this session, we are going to concentrate on tests of an induction motor. What are the different type of tests we are going to conduct to know the performance of induction motor in practically in our laboratory also. Here the first one is the no load test and blocked rotor test. Mainly we are going to conduct to know the motor, the parameters. Let us, what are the objectives of today's class, we will see. What you have seen in previous classes, the exact equivalent circuit or as referred to stator we have seen, and approximate circuit as referred to the stator also we have seen, and phasor diagram of induction motor we have seen in previous classes. How to draw the phasor diagram, how to find the equivalent values in an induction motor, that is equal to R0, X0, R01, X01 referred to the primary side. These parameters can be found by conducting few simple tests. Okay. So, what are today's objectives? On completion of this topic, the student will be able to conduct the no load test and blocked rotor test on an induction motor. Second one, able to draw the performance curves of induction motor. Testing of induction motors. To know the performance of induction motors, the following tests are conducted. First one is the no load test. Second one is the blocked rotor test, and finally stator resistance test. These three tests we are going to conduct in our laboratory also. Every student of diploma, you should know how to conduct no load test on a induction motor and blocked rotor test on induction motor. So, these tests are similar to the no load test, SC test, open circuit test, and short circuit test on a transformer, similar to the transformer. You have performed the no load test on a single phase transformer and short circuit test on single phase transformer. By conducting those tests in previous classes, you have find the X0, R0 and Z01 refer to the primary side. Similarly, under standstill condition, our three-phase induction motor looks and works as a three-phase transformer. Here we are going to conduct three-phase induction motor with help of some meters, voltmeters and ammeters, wattmeters. To control this one, we require the one auto transformer. Okay. So, we will see this test one by one in details. Okay. So, to conduct no load test of an induction motor, what are the requirements and what are our aim to find the values? So, a requirement is we require the three-phase induction motor is required and auto transformer is required to control the rated voltage, and one voltmeter and ammeter and W1 and W2 wattmeters is required to find the power consumed by three-phase induction motor. Okay. So, after conducting this test, what are the values we are going to find it? Okay. What we have calculated what you are found in no load test on a single phase transformer. So, in single phase transformer, what we have done? So, we have given the rated voltage to the primary side and the secondary side open circuited, and during the starting rated voltage, it will draw the very less the primary current, which is utilized for the production of magnetic field, that at the same time to meet the working field, that is called I mu and IW, that is the sum of these two vectors IW plus I mu equal to the I0, that is the I0 is equal to no load current on a transformer. Similarly, here we are going to conduct the same test on 3-phase induction motor. Okay, let us, what we are going to find, what are the values is required. So, first we will see it. From no load test, to find out, one is the no load losses, no load power factor, no load resistance, that is equal R0, that is a constant, no load reactance X0, that is constant. This test is same as the no load test on a single phase transformer. The no load test of induction motor, how to do this one? So, we will see. So, here the no load test, the no load losses, what the losses consist of this one. In transformer, there is a iron losses and copper losses, but whereas in case of the motor, there is a mechanical losses. Friction and windage losses also plays a vital role in performance of the induction motor. Now, so what are the no load losses here? One is the core loss and a small amount of copper loss in stator winding, because initially the no load current is a very less, that is called I square R, losses of stator is a very less, we are neglecting. And second one is the rotor copper loss. Here it is also negligible due to the low rotor current at no load condition. And finally, so we are going to know that friction and windage losses, that is the mechanical losses. These are the no load losses. To meet these losses, it will draw the current from the supply. The current is very less. Okay. Now, these are the losses occurred at no load condition without any load on a motor. Now, how to find the how to do the no load test of an induction motor? Okay. So, we will see that one. Now, here you can see the diagram. What is this one? Here is this is the stator and this is the rotor. When stator is given 3-phase supply to this one, here R phase and Y phase and B phase supply is given, and we connected the one voltmeter here across the R phase and Y phase, and one ammeter is connected through in R phase. To find the current in a R phase, we assumed this load is a balanced load. So, whatever the current in one phase, that may be similar to the remaining phases, and voltage between the R and Y phases and Y and B phases and B and R phases are equal. And here we connected the one W1 and W2 in between the two phases. Two wattmeter methods we are going to adopt here to find that what is the current power taken by this or motor. Okay. So, here out of these are the connection diagram, dear students. So, this test you are going to do in our laboratory compulsory. So, everyone has to learn. Okay. So, we will see in clearly with the diagrams. Okay. Let us see. Now, first we will see the no load test. What is that one? No load test. Okay, now here I am going to do the no load test. Okay, no load test on an induction motor. Okay, so how to do this one we will see. Now let us draw the diagram. Okay, let us assume this is a 3-phase induction motor. It has a rotor. A rotor is connected through the belt. Here connected the 2 spring balances and it is connected to the support. So here is a spring connected. Here is the another connected here. Okay, these are the spring load spring. This is the S1, this is the S2. So this is the rotor. And here we connected 3-phase supply, and this 3-phase supply is connected here. We take the R phase, Y phase and B phase, connected ICTP switch. Okay, then is connected the fuses, and from this one we connected one auto transformer, variac, 3-phase auto transformer. Okay, so we connected this 3-phase auto transformer. From this auto transformer output terminals, it is connected to one phase R phase, one ammeter, and is connected this one to this one, and we connected this one to this one. Here are connected. Okay, we will see another voltmeter also. Okay, so we will connect to the voltmeter. Here I am connected the 1 voltmeter across 2 phase. Okay, now this is the voltmeter. Voltmeter connected. Now is connected to this one. Here I want to connect the 1 wattmeter. Okay, so how we are going to connect the wattmeter? So this is a CC coil connected to this one, and PC coil is connected through this one. Okay, so this is equal W1, and here we connected the another CC coil connected here, and here connected the another PC coil. This is equal W2, and W1 and W2 are 2 wattmeters. This is the 1 wattmeter and this is the 1 wattmeter. The CC coil connected in B phase and PC coil connected between the B and Y phase. You can see here. Okay, this is the ammeter. It will measure the current, and this is the voltmeter. It will measure the voltage, and this is the W1 wattmeter. This is the wattmeter. Okay, so this is the connection diagram. Okay, you have to connect to the all meters, AC meter, MI meters, such a way that, so here voltmeter will measure the voltage between the 2 lines, and ammeter will measure the current in 1 phase, and W1 and W2 are connected in 2 wattmeter method. So it is measure the what is the power consumed by our motor. Okay, so this is the connection diagram of induction motor under no load condition. So what are the precautions you should take before starting the experiment? So here this is the IC, what is this one? IC TP switch, iron clad triple pole switch. Okay, this is a switch and this is a variac. Now what is happen? Close the ICDP switch. Before closing the supply, you should ensure that the rotor of this induction motor should be very loose. There is no tight belt here. There is no load on this one. Okay, so here the rotor will rotate freely without any friction. Now after ensuring this no load on rotor, then close the IC TP switch, then slowly vary the voltage. You can observe here, once you are going to increase the voltage, this is a 3-phase voltage, 0 to the 400 volts. Okay, this is a 0 to 400 volt 3-phase supply. Once you are going to increase the voltage, what will happen? So, ammeter will draw the more current, it will indicate the more current, don't bother. And voltmeter slowly increasing. Now, at that condition, once you are going to increase the voltage at suppose nearly 60 to 70 volts or nearly 100 volts, it will draw the more current from the supply. You can observe why. We know that at standstill condition our rotor is n speed is equal nr is equal 0 at standstill condition. Then there is no back EMF in the motor. Due to this one we draw the more current from the supply. There is a starting current. What is the starting current? The starting current any motor will draw due to the no back EMF, it draw the 5 to 7 times of full load current. Okay. So, due to this one the current will draw the more current. This can be observed by in ammeter. Without any load, while you are going to increase the voltage with the help of the variac, then ammeter will show the more current. Don't worry. Then slowly increase it. Once it increases, the rotor starts to rotate. Once rotor is rotating, so increase some more voltage and wait for few seconds. Then rotor will pick up its speed up to the rated speed. Once the rotor is rotating up to its synchronous nearby its rated speed, you can observe that the current in the ammeter falls to back to the low values. You can observe it. Before starting the rotor, the current is drawn from the supply is increasing in mode, while the rotor is rotating in clockwise direction, for example, then automatically the deflecting torque produced in ammeter will decreases, hence the pointer will starts to comes towards the minimum values, come to the low values. You can observe it. Once the rotor picks up the maximum speed, then you can start increase the voltage up to rated voltage. In this case, what is the precautions? In no load test, you have to give the rated voltage to the stator. What is the rated voltage here? That is equal 400 volts. The rated voltage 400 volts given. Then the rotor is rotating at normal speed. So, this is the starting method of induction motor. Dear students, at the same time you can observe one thing also. What is that one? Due to the no load test, initially it will draw the more current, after that it will comes to the low value, but whatever the W1 value and W2 value, both meters will show the one of the meter will show the reverse deflection. You can observe it. Why? So, as we know that the power factor at below 0.5, one of the wattmeter will show the reverse direction. Okay. So, what to do now? So, in that case, so what we are going to do it? So, simply come to the rheostat to the normal position and come to the 0 voltage, open the ICTP switch. Then here you change the W1 wattmeter CC coil or PC coil connection. That means what to do here? You know that this one. So this is a MLCV. So you connect. This is a CC coil. Okay, this is the PC coil. You know this one. CC and PC coil. Wattmeter reading. This is a wattmeter reading. So what will happen? So initially you are connected the M as a supply and L is the load. Okay, ML. Now M and C is the shorted and this is connected to the another phase. For example, you connect to the R phase, you connect to the Y phase. In this condition, what is happened? Instead of moving the pointer this direction, it is moving in this direction, opposite direction. That means the torque developed is a opposite direction due to the low power factor. Now, in this case, we are going to do what we are going to do it. So here, what are the M and this coil? M, this is a L, and this is a C and V coil. Similarly, now you give the supply to this one, directly give to the L, and you take the L to this load. Okay, it's connected to the load here, and this is connected to the main supply. Very supply connected. Then what is happen? In this condition, the current is flowing in the opposite direction. Then deflection will, instead of going this direction, then it will go this direction, opposite direction. So dear student, don't change both. You can change only one coil at a time. Now this is a similar. So whatever the is connected, the main supply is connected here, and this is connected to the V, another phase. Okay. So then what will happen? It will show a reading in opposite direction. That is equal the wattmeter reading. Now it will show this direction. So whatever the value from this one 0 to this value. So you take that reading, for example 60 watts. Not simply 60 watts. If we have to take the minus 60 watts, you take it. That means W1 reading is equal to minus 60 watts. And one of the other two meters, whatever the meter W2 will shows, that will take the reading of, for example, it may be 100 watts, positive 100 watts. Then what is the power? The power is equal to W1 plus W2. Then what is happen? Minus 60 plus 100. So that is equal 40 watts is a no load power consumed by our induction motor. Okay, so these are some precautions, techniques you have to handle the no load test. Okay, so one of the meter shows the reverse direction. At that condition, you change whether the CC coil or PC coil connection. Then the meter will shows the opposite direction to the previous case. Then take that reading into minus value. Okay, so this is one technique you have to remember. Okay, now here W1 and W2 are, we change this one, we take in the W1 then W2. So how to conduct the test now? So this is our connection diagram. We are given the circuit diagram, connection is given as per our circuit diagram. So R phase, Y phase and B phase is connected through the ICTP switch. From the ICTP switch it is connected to the variac, 3-phase variac, and it is used to control the voltage input to the motor. Now the voltmeter is connected between the R phase and Y phase, and one ammeter is connected between the R, so that is between the variac and the wattmeter M coil. And W1 is connected in between the R phase and Y phase. CC coil is connected in series and PC coil is connected between the R and Y. Similarly, W2 wattmeter second one is also connected in between the B and Y phase, and the CC coil is connected between in B phase, and PC coil is connected between the B and Y phase. Okay, here W1 and W2 are both 2 wattmeters connected and to the motor terminals. Okay, so these are the connection diagram of induction motor. Here S1, S2 are the 2 spring balances. So you have to initially keep it as a no tension case. Okay, so this is you have to remember.